Welcome to the walkthrough of the frequently made mistakes for assignment 1B. First, please make sure you comment your code consistently. Far too many people are just writing code but not explaining what they're doing, and therefore if you have problems, it takes longer to figure out how to explain to you what you need to do to fix them. And just get in the habit of commenting code. It's a good habit that'll benefit you throughout the rest of your career. Also, make sure you run the tests, the unit tests and the integration tests, and also come to office hours or post on Piazza if you have any problems. If your tests are failing, don't just sit there and scratch your chin and wonder why they're failing. Come and get help and then fix those problems before you submit the code for review. Likewise, as you've no doubt noticed, I put out sort of incremental frequently made mistakes videos. So make sure you watch those frequently made mistakes videos before you do your initial submission and do your best to address those points that I address in my frequently made mistakes video before you do your initial submission. So that way it will take less time with the turnaround because you'll already have given a shot to try to improve the problems. And of course, if you're confused and need help, don't hesitate to get help through office hours or Piazza. Now you'll see there's a lot of issues here. Some people did very well, other people struggled. So I'm going to go through a bunch of different frequently made mistakes. This is a bit of a long video, but hopefully it'll help clarify some problems people have been having. So first of all, make sure you don't use static fields for the fields that you define for Rantrate lock or for the spin lock, hash map manager, and so on. These should be non-static. Secondly, remember that if you're doing the grad student version, that atomic reference is a generic type. So make sure you use the correct syntax in order to instantiate it with a type, in this case, thread. Also, you don't need to use anything like an atomic integer. You can just use an int to keep track of the recursion count. This, again, is for the grad student version. Now we're getting into the nuts and bolts of the implementation. Some of this stuff will be relevant for the grad student version. Some of this will be relevant for the undergrad version. Some of it will be relevant for both, and I'll try to make that clear in my comments. This is a nice helper method, but this code is too complicated. There's no need to check get ID, current thread, get ID, blah, blah, blah. Way too complicated. And you can make it a lot simpler. That was obviously for the grad student version. Down here's the try-lock implementation here. This particular try-lock implementation is too complicated, so we don't need to do all these checks for current thread and recursion count and so on. Just go ahead and make a simple call to compare and set on the underlying atomic field. And you can actually make that simpler. You don't even need an if-else statement there. So just make it really concise. Here's another problem with try-lock. This is a deeper problem with try-lock. Set and get are atomic in and of themselves, but they're not atomic with respect to being called across a scope or a span of methods. So this particular approach has got race conditions in it. Don't use set and get like this. Instead, use the appropriate compare and swap style method. And if you watch the video here, you'll know which one I'm talking about, so I don't want to totally give it away, but make sure you're using the compare and swap style method on your atomic field. Likewise, try-lock is a one-shot thing. It should not be called in a loop. So make sure that you use the appropriate method here, and you just have to do it by doing a return. Just return of this comparison with the right parameters, and all should be well. Should be very, very simple method. Let's now start taking a look at some of the problems in lock. A lot of people struggled with lock. So first of all, you don't have to use the equals method. Just use the equal operator instead. For the grad student version, please get in the habit of using plus plus or minus minus instead of plus equal 1 and minus equal 1. Just a bit more concise. Down here, factor your code out so you don't call compare and set again, but instead reuse your try-lock method to factor out that common code. And also, get in the habit of calling mowner. Now, this is going to depend on what version you're dealing with, but it probably should be something like mowner dot get equal null before calling try-lock in order to improve cache performance. Now, as it turns out, this is just a little bit tricky to get right, and there's various ways to do it. So I'll leave it to you to figure out how to get the logic correct. There's 3 or 4 different ways of getting the logic correct. But you want to call mowner.get and check it to see if it's null before you call try-lock. And the reason for that has to do with caching and bus overhead that you get with these atomic compare and swap style operations on modern multi-core processors. This code is way too complicated. Just use the isCancel.get method and make the test correct. And there's no sense in calling try-lock again here. I don't know why it's even being done because the return value is not being set or checked. Down here, please make sure you call the thread yield method in the context of the loop, be it a while loop or a for loop, in order to allow another thread to run if it's ready to run. That's just kind of an optimization here. Let's take a look at some more lock problems. We don't need to check to see if mowner equal null. That should have been initialized in the field above. When you actually define what mowner is, you should initialize it. Also, in this particular case, this code has got race conditions because we're using get and set instead of using the compare and swap style method. So make sure you go back and rewatch the videos on compare and swap operations to understand how they work. And this call, they put the yield method in here, but the yield method needs to go in the while loop, not just at the very end of the method. That doesn't help at all. Let's take a look at some more subtleties with lock. mowner will never be null, so you need to call mowner.get in order to get the value that's stored by mowner and check that to see if it's null. You have to write this code carefully to make sure you get the logic correctly. It's a little tricky. This is an example of code that is not got the logic correct, so it's very, very tricky. You have to think hard about how to make this check right. Some people felt better writing it as an if statement inside of a forever loop. A forever loop is a loop that looks like this. And then you can do something in there, if, blah, 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 break. So that's another way of being able to implement the logic. Or you can do a while loop. Either way is fine. Also, please make sure you call yield after you check to see if the lock is canceled. This is the call to cancel lock. That needs to go above the call to yield. And I don't know why some people did this, but there's no need to set the owner to true because that's exactly what try-lock does atomically. So make sure you just use that. You don't need to set this to true yourself. That's already been done by the time you get to this point. Down here, you need to also check for mowner.get equal null each time before you call try-lock, not just once at the start of lock. That doesn't help you. And again, should be .get here instead of saying null. But in either case, you shouldn't do it just one time. If something goes wrong and you need to throw the illegal monitor state exception, make sure you give a message saying what happened. Put the message in here somehow that gives more informative information than just nothing. As I mentioned before, get in the habit of using the auto increment and auto decrement methods like hold count minus minus instead of hold count minus equal 1. And down here, this is for the grad student version, you actually don't need to use get and set. You can use set for various reasons, just because of the semantics of recursive lock. So there's no need to use get and set here. Down here, I'm not quite sure what the person was trying to do, but this is the wrong implementation. You don't want to use compare and set. You want to use get and set. That's the right method to use. And you also need to make sure you check the return value of get and set correctly. Speaking of get and set, the nice thing about it is it's a single atomic call. And so instead of calling mowner.get followed by mowner.set, which I think will actually work, but this particular logic has more steps than you need. So just get in the habit of using get and set. And it's a good method to know about. It's very cool. Another thing to keep track of here is if for some reason get and set doesn't succeed, that means that something's gone wrong and you need to throw the illegal monitor state exception. So as the comment says up here, make sure you refactor your code and put the checks in and throw the right exception if you need to. Okay, now it's time to turn our attention away from all the spinlock stuff into the spinlock hash map manager. And a couple things to note here. Please use private instead of public for the fields. And so do that both for spinlock and for semaphore. And also make sure you use the super type, not the subtype. So spinlock implements a super type. And you want to make sure that you use the name of that super type here, not the name of the subtype like spinlock or rampant spinlock. That makes the code more flexible. Down here, please get in the habit of using the for each method and a lambda expression instead of a for each loop. This code is correct, but let's just try to get in the swing of using modern Java features. Make sure you give the right count to the semaphore. It's not 1. It's going to be the get Palantiri count method. Make sure that you also, when you allocate your new spin lock, don't just turn around and reassign it again. This code is duplicative. You don't need to call the accessor methods in your implementation code. They're really only there for testing purposes. And as we've gotten better testing frameworks, we're actually getting rid of these accessor methods altogether. So I think in future assignments, you probably won't even need to use them at all. So this is an inefficient and in fact incorrect way of trying to set all the Palantiri in the map to true. And the reason it doesn't work is because there's no terminal operation at the end of this stream, and it's also just overkill, so we don't need to do it. This code is supposed to initialize the semaphore. This code is supposed to initialize the lock, not call the methods on uninitialized semaphores or uninitialized locks. So that's obviously going to cause problems. This again reminds me to inform you to make sure you run the unit tests and the integration tests. They will catch most of these kinds of problems. And we keep improving the unit tests and integration tests with every new release. So more and more things should get caught over time, which means you may have to fix your old code because undoubtedly there'll be some things that I missed or you missed that will now be flagged automatically. There's no need to call is canceled in a loop. I'm not quite sure what that's supposed to be doing, but that's wrong. Also, make sure that you pass the right method reference to the lock call. Making a supplier that just returns false is not a good idea. That won't do anything useful to check if something's been canceled. So instead use the is canceled method reference. This check is unnecessary. There's no need to check what the state of the thread is. I'm not quite sure what that's trying to do. And also make sure that you unlock locks. Make sure you call unlock on locks, be they spin locks or rantrant locks or stamp locks inside the finally block in a try finally statement. And also, very important, do not call release in acquire, since that totally defeats the whole purpose of using the semaphore. That the count, when you acquire the semaphore, that increments the count by 1, and that makes sure that no more than n being threads can gaze at the n available Palantiri. So make sure you don't call release here. Also, don't be commenting out the throw to illegal state exception. Just refactor your code so that this code will compile and do sensible things. All right, let's continue talking about acquire. Lots of different problems with acquire. So first of all, there's no need to put calls to the semaphore acquire and the spin lock method or field in try catch blocks. No need to do that. Doesn't do you anything good whatsoever. Just don't do it. You also don't need to call these helper methods like get spin lock and get semaphore directly. Just access the field. We're actually going to fix this in future versions, so I think it'll yell at you if you try to do that. In fact, we're getting rid of those methods altogether, I believe. So make sure that when you actually do the logic for finding the appropriate available Palantir, that you put it in a try finally block or in the try portion of a try finally block so that we don't end up having problems if exceptions are thrown with forgetting to release the lock. This expression is too complicated. Just use a simple method reference. Also, this particular code down here is the wrong way to do this. We don't want to be using map get key here. Instead, you should be using some logic we'll talk about a bit more later, where you're going to take the value, which we know to be true if it gets past the filter, and then set it to be false, and then return the key. So that's what you should be doing there. And you definitely don't want to be making any calls to replace in acquire. That's unnecessary and extra overhead because we have to rehash the Palantir multiple times, which is inefficient. Make sure that you comment your code if you write code like this, and also don't write your streams code like this. It's very hard to read it. It tends to run off the right side of the screen, and it's hard to comment it. So put it in this format and then put comments here. And then you also want to make sure that you put the call to the map up ahead of find first. And some people were confused because they said, oh, doesn't that mean we're going to set all these things to false? No, that's not the way in which streams work. Streams work from top to bottom, left to right, not left to right, top to bottom. And what that basically means is that there's this find first method is so-called short circuiting, which means it'll stop as soon as it gets the first thing that it needs to get. So don't worry about setting all the values to true or all the values to false or whatever. It's very convenient to do it by moving map ahead of find first. Also, this code will blow up if find first returns null, and that's because find first will basically return an optional, and so if there's a problem, you don't want to just call get, you need to use the or else null method here. Or else is defined on an optional, and it either returns the value of the optional if it's present, or it returns what you provide as the parameter to or else, which is, in this case is null. Yet some more problems with acquire. We don't need to be calling try lock here. Make sure that you move the calls to acquire and lock outside of the try block. You want it to go before you call the try block. That's because if something goes wrong with the lock, we are not trying to unlock a lock that was never initialized. So you have to get in that habit. It's a very important idiom with Java. And also, you need to pass a parameter here to lock. This code won't even compile. And there's no need to have this catch clause. So let's say, make sure to not use a catch clause here, because it's not going to do us any good, and we don't need to be calling shutdown now in the context of this method, and so on and so forth. Yet some more problems with acquire. So I guess one thing to note here is this code isn't synchronized, so there's no call to lock and unlock the spin lock, so that's one of the problems here as well. And also, don't be using key set. That's the wrong thing to use. Use entry set. And don't be using get here. Instead, use the get value and set value on the entry set methods in the for each loop if you use a for each loop, or you can also use streams. But in both cases, work on entry sets, not on Palantiri. This code is very inefficient. Don't be doing gets and puts. That's really slow. Down here, make sure you use a method reference instead of doing a lambda expression. Just a simple thing your compiler should probably tell you, your IDE should tell you that you can do that transformation automatically. Please, again, use entry set instead of key set, so the rest of the code will be more efficient. You don't want to be using get here. Instead, use map.entry : get value. That's what you should be filtering on. And again, this code is unnecessarily inefficient. Either use a for each loop that iterates through the map's entry set and uses get value and set value accordingly in conjunction with get key, or add a map call above, as we talked about earlier, after filter that will use set value on the entry set to change the value of the entry set to false, thereby indicating that Palantir is not available. And also down here, please get in the habit of using false instead of boolean.false. That's overkill. Okay, so let's go down now and take a look at release. There's a bunch of issues with release that are somewhat akin to the problems with acquire, but they have their own unique set of issues. First of all, you don't need to check for interrupts, so that could go away. First and foremost, make sure you check to see if the Palantir parameter is null. And if so, you want to bail out. Now, with a subsequent assignment, starting with the next assignment, you'll have to throw an exception. For assignment 1B, just ignore that anything has gone wrong. Just ignore things and don't make any changes. Another tricky issue here is that by calling replace on the Palantiri map, you can end up getting 3 values back. You can get back a null, you can get back a true, you can get back a false. And we're going to also be doing more strict checking for this in subsequent assignments. Don't worry about it for now, but basic bottom line is you'll have to think about this a bit more carefully down the road. If the map has correctly done things, in other words, if you were able to replace the Palantir false to true in the map, then you want to do an unlock, except you want that unlock to be called just one time, and it should be performed in the finally block. You shouldn't have what this code does, which is call unlock twice, and not call it in a finally block. Here's some more problems. Don't call release if Palantir equal null. At the moment, just ignore it. Subsequent assignments will have you throw an exception, an illegal argument exception. Don't worry about that yet. That'll come with next assignments. This code is full of race conditions since the spin lock isn't acquired, and it's also way too verbose. Use put or release on the hash map, and then check the return value. And don't call release here on the semaphore blindly. And we'll talk more about what I mean by that in a second. Here's some more problems with release. Don't be calling get here. Just check to see if something is null. Make sure you don't call the lock method inside the try portion of the try finally block. It needs to go before it because bad things will happen if lock throws an exception. Down here you can see, also you should not be calling get spin lock. You should just give the name of the field. No need to call contains key. Instead, just use replace or put. However, when you call replace or put, make sure you get the return value and see what the results are and then act accordingly. You only want to call release if the call to replace succeeds. In other words, you actually are able to change it successfully from false to true, and you don't get back a null and so on. And you also want the call to release to go after the call to unlock. So there should be a call to unlock down here in the finally part, but you want to release after you unlock. And the reason you want to release after you do the unlock is that that's more likely to wake up a waiting thread who will then be able to come in and find the lock is available rather than calling unlock, which could wake up a thread and then it would come in. I'm sorry, if you call release first, that'll wake up a thread, but the lock would still be held. So make sure you call release after you unlock the lock. And then the final issue here is you don't need this check. You don't need to check if spin lock equal null, and you don't need to throw the cancellation exception in that case. Okay, so you can see there's a lot of stuff going on with assignment 1B. Many people did very well, so congratulations. Other people have bits and pieces of the various problems that I've identified here. So you have, I think, about 4 days to fix all this. Please take a look at the website to find out when the next version is due and the final version of assignment 1 is due. And that version should contain all the fixes for comments and frequently made mistakes for assignment 1A and for assignment 1B. And we will go ahead and grade that submission.